No. Our objective for today, I can factor quadratic trinomials with leading coefficients greater than 1. Let's read together. 1, 2, 3. I can factor quadratic trinomials with leading coefficients. So notice we're showing the same objective from yesterday, right?
Yes.
And the day before, right? The only thing today, we're going to look at a couple of special products that are called difference of squares and perfect squares. And so today's basically, it would be it's going to be a very simple lesson. It's just about patterns. That's where we don't need a fair model or steps. So watch. So with that said, we know what a quadratic trinomial is, right? We know steps, right?
Yes.
Okay. Therefore, the first term that I want you to write down on your notes, write this down. Perfect. Oh, it's on free, sorry. Perfect square trinomial.
That's the first thing you write?
That's the first thing you write. Perfect square trinomial.
Yes.
So now check this out. First, what I'm going to do, I'm going to show you first what it is, and I'm not going to give you a definition because the definition is within the term. Watch. This is a perfect square trinomial. Let's read it backwards so we can understand the definition. It's a what? Trinomial that is a what? A perfect square. So before I give you an example of a polynomial that looks like that, let me show you first an approach just with numbers. Now, this approach that I'm going to show you right now, I showed this to third graders.
What?
Yes. I showed this example to third graders and they understood it. So I'm going to start exactly how I showed it to them. So here we go. When I used to teach in Calexico, I had a couple of schools that were right next door, elementary schools. For example, let's say here at the AMPM there's one elementary and another one over here to the side, like going towards no, that's far away. I'm saying right next to, where I can actually walk across. So some of my teacher friends from across the way, they would ask questions in regards to certain approaches, and I would say, you know what, I have prep first period, so whenever you guys want me to go and teach a lesson, let me know. They would tell me, can you come teach a lesson this day? So yeah. So they would get all their teachers together, like their third grade teachers, there was 4 of them. They'll go to this one class, and I would teach the lesson to the kids. Except for the other teachers, they would have subs that day, right? So then, or that period. So then I would teach a lesson, and this is the lesson that I taught. Here it goes. So the first thing that I showed them was, first of all, I wanted to show them what a perfect square trinomial was. So, third graders, here it goes. Perfect square. First, let's cover perfect square. I asked, what is 12 times 12? 144. Write that down, please. 144. 144 is a perfect square. So right now we're working on perfect square, right? So then at that point, their minds were like, wait a minute, square and we're dealing with numbers? I don't get it. I saw their faces, right? They didn't say that, but I saw them. I said, now let me clarify. This is called a perfect square because of this. If I was to draw a square, hold on, and I did this, a perfect square, that means that this measures the same as this. Is that correct? Yes? Therefore, if one side measures 12, what does the other side measure? 12. Therefore, this is 144 for the area. And guess what? This is what we call a perfect square, when this number comes from the same number being multiplied. Copy that, please. So, are we good up to right there?
Yeah.
Everybody understands what a perfect square is. So, what would be another perfect square? 100, right? Because 10 times 10, what other? Yeah.
11 times 11.
11 times 11 is 121, so 121 is a perfect square.
20 times 20.
Which is?
400.
400 is a perfect square.
Negative 20 times 20.
No, that's not a perfect square.
That's
It's
a
a
zero
negative.
pair.
Damn. So, hold on. So everybody knows how to get a perfect square, right? Multiply the same number times itself, and that gives a perfect square.
14.5.
So-
14.5.
Amari, what's another perfect square number?
Stop talking to me. 5
Being-
times 5.
5 times 5, which is? 25 is a perfect square numbers, right? So the students understood that, and I said, okay, but now let me show you what we do at the middle school level. So they're like, this, what's that?
Were you teaching in Spanish or
No,
no?
in English.
Oh, why didn't know?
Is that supposed to be a racist show?
Anyways, look up, please. So I said, this at middle school is what we call the area model. Except for at the middle school, instead of having just one number, they have two numbers. So watch. I said, what if I can rewrite this number like this? Do you agree that this is 12?
Yes, I do.
Yes, so how can I write the other number? 10 plus 2.
You choose
So
10.
So look at this. This, I'm going to rewrite in a different way, but that is exactly the same. But instead of 12, what am I going to write?
10 plus 2.
10 plus 2,
The box.
10 plus 2, and what is this called? The area model. Copy this, please. And yes, third graders did this. Here we go. So what is 10 times 10? 100. What is 10 times 2? 20. What is 2 times 10? 20. And what is 2 times 2? 4. So now, no, because it's simple math.
Well, we didn't get taught this, you know why?
Okay, here we go. Look up, please. So at this point, we know this is a perfect square, right? Does everybody agree that this is the same as this?
Yes.
All right. So if I was to rewrite this, check this out. Now, I told the kids that we're going to rewrite it with placement. Who remembers placement back in elementary, middle school? I mean, first years, right? Units, tens, hundreds, thousands, right? So I'm going to start with the hundreds. What goes first? 100. What goes next to tens? So we have 20 plus 20, that's what? 40, and I draw my peanut, that's 40. And what are my units? Plus 4. Well, guess what? This is still a perfect square, isn't it? But now how many parts do we have? That's what we call a trinomial. This is what we call a perfect square trinomial.
Mr. Q, you know what I learned when I was in...
Okay, hold on. Let me finish up. So, are we there so far? So we know that this is a perfect square because it comes from in here and this is the same as this, right? And it's a trinomial right now. All right? But then I said, guess what? If I was to give you this and I asked you to come up with these, the original measurements, I'm going to show you how to do that. So watch. I'm going to cover this up. And I'm going to show you how to get the factors of this perfect square trinomial. Watch. Here it goes. First, let's check to see if this is a perfect square trinomial. How can we check? Pay attention to this or you're going to miss it. First, can we take the square root of the first number? Yes. What is square root of 100?
10 times 10.
10. What is square root of the last term? 2. So watch. What is 10 times 2? 20. And if we double that, does that give us this number? Yes. Therefore, that's how we can check if it's a perfect square trinomial. If it is, if we find the square root of the first, square root of the last, we multiply them and then we double it. If it does give us this number, then look at the factors. The factors are right here. 10 plus 2 squared. Copy that, please. Next. So now look at this. So now we know what it looks like. Let me double check to see if we got this. Let me move this out of the way. So, I said 12 times 12 is 144, and I said 144 is a perfect square, yes? Because if we put it in a square, 144 comes from 12 times 12. That makes it a perfect square number, yes? But then I said, let's rewrite this. We can rewrite the 12 as 10 plus 2 and 10 plus 2. And I said, let's do this area model again over here, but instead of writing 12 and 12, we're going to write 10 plus 2, 10 plus 2. So everybody understands that this is the same as that. Are we there?
Yes.
Yes. The only thing we wrote it differently. From there, we rewrote this area, and all of a sudden now we ended up with a trinomial. But it's still a perfect square. That's why it's called a perfect square trinomial. So I said, in order to check if it's a perfect square, we square root of the first, square root of the last, multiply and double that, and if it gives us this middle term, it is a perfect square. If it's a perfect square, therefore, the two factors that we got, we just write them with a plus or a minus, and that gives us our factors.
When would it be a minus?
So when this would be a negative. Yeah. So for right now, we'll stick with the positive. So now check this out. Let me show you another one. 100 plus blank plus 9. So let's see. What is the square root of the first?
10.
Square root of the last?
3.
What is 3 times 10?
30.
What is 30? Double that.
60.
So what needs to go here in order for this to be a perfect square? 60. So now it's a perfect square, so if it is, then what are my factors? 10 plus 3 squared.
Oh.
Everybody got it? Okay. So copy that, and then right now I'm going to show you with algebra. But yeah. Bam. So, now that we have this, now let's do this with algebra. Copy this example down, please. Example 1A. Label it. Determine, write this down. Determine whether each trinomial is a perfect square. If so, factor. If not, explain.
We write everything, like all that, everything. Yay.
No, only the blue and the black text. You don't have to copy the white text on top.
Okay.
And we move this a little bit out of the way. Alright, here we go. Pens down, eyes up here. So I'm going to use a pattern because I want to see, they're saying, is this a perfect square trinomial? Let's find out. What was the pattern? Find the square root of the first term. What is square root of 81x squared? 9x. What is the square root of the last term? 5. So what is 9x times 5? 45x. And if we double that, does that give us the middle term?
Yes.
If it is, if it does, then it is a perfect square. And they said, if it is, factor it. So what are my factors? 9x plus 5 squared. And we're done. Copy that, please. Okay, let's do another one, just to clarify. Here it goes. Copy this one. Example Q. 16x squared plus 16x plus 4. So let's see. Let's check to see if this is a perfect square trinomial first. What is square root of the first term? 4x. What is square root of the last term? 2. What is 4x times 2? 8x, and if we double that, does that give us the middle term? If it does, then my factors are 4x plus 2 squared. Hands if you got that. Okay? So, are we there so far? Okay? Copy this next one. You don't have to copy the instructions anymore, just copy the trinomial, please. Example 1b, 9x squared minus 15x plus 64. 9x squared minus 15x plus 64. Let's do this one together. See if it's a perfect square trinomial. So what is the process? What is the square root of the first? 3x. What is the square root of the last? 8. What is 3x times 8? 24x. And if we double that, does that give us the middle term? So then this one is not a perfect square. Why is that not a perfect square? Then you will explain, because if I take the square root of the first, the square root of the last, multiply them and double that, does not give me the middle term. Does that make sense? So let me ask you a question, a follow-up question. If I have this, 9x squared, and then the last one is 64, what should go here in order to make it a perfect square? Don't say it out loud. What should go here? Notice that I got those numbers from here. What should go here? Andrew. 48x. So my perfect square trinomial is what? 9x squared minus 48x plus 64. Does everyone understand? And if this is a perfect square, then what are my factors? 3x plus 8 squared. We got it? Okay. Let's go to the next one. I got it from here. Okay, copy this next one, please. Example 1c. Not this. This is algebra. Yeah. See if you can do this one by yourself. 1c, get it? Let's see. 36x squared minus 10x plus 14. Go. All right. Let's see. Help me with this one, please. Evelyn. Square root of the first. 6x. Square root of the last. It doesn't have one, so therefore this is not a perfect square. Why? Because what would you say? Because the last term is not factorable. You cannot find the square root of the last term. Pretty simple? Let's do another one. Copy this one. Example 2a. X squared plus 4x plus 4. See if you can do that one by yourself. If it is a perfect square trinomial, find me the factors. Go. Okay, let's see. Help me with this one, Edgar. Is this a perfect square?
Yes.
Yes. And what are the factors? 1x plus 2 squared. Hands if you got that. That is correct. Now how do we check? Square root of the first, x. Square root of the last, 2. Multiply that, that is 2x. And if we double that, does that give us the middle term? Yes. So my factors, I got them from here to write it like this. Copy this next one down, please. Example 2b. X squared minus 14x plus 49. So let's do this one together. Okay, I'll give you guys a little bit of time to see if you can go ahead of me. Go. Alright, now check this one out. Look up, please. This one had a little curveball to it. Here it goes.
It's only because of the negative sign.
Yes, here it goes. Square root of the first, x. Square root of the last, 7. Multiply that, that's 7x. Double that. Does that give us 14x?
No.
Yes.
Yeah, but it's a negative.
But it's a negative, therefore, x minus 7 squared. Bam.
What the heck?
How we doing? All right?
Pretty good, pretty good.
Do another one?
Wait. I need to write that down.
Let's do another one. Copy this one down, please. Example 2C, because I want to see if you got these by yourself. Here we go. Example 2C. 9x squared minus 6x plus 2. Go. I mean plus 4, sorry. Go. Okay. What'd you get for this one, Juvia? She said, not a perfect square. Why, Juvia? If you multiply square root of the first, which is 3x, times square root of the last, which is 2, this is 6x, but then you do what? Double it. It's 12. Is this 12? No. Yeah, make sure you double at the end. Copy this next one down, please. Example 3. Oh, wait. Here goes. I'm going to read it, but I just want you to copy the trinomial first. It says, a rectangular piece of cloth must be cut to make a tablecloth. The area needed is 16x squared minus 24x plus 9 inches squared. The dimensions of the cloth have to be as in a binomial, where C and D are whole numbers. Find the expression in the perimeter of the cloth, and find the perimeter when x is 11. So first they want dimensions, right? So let's copy the trinomial. So the trinomial that they give us is 16x squared minus 24x plus 9. See if that one's a perfect square. If it is, find me the dimensions of that cloth. Go.
Whoa.
Alright, let's see. Can you give me the dimensions for this one, please? Go ahead, Sydney. With the dimensions? No, Sydney. You got him? Let's see, help me out, Sydney. What is the square root of the first? Let's see, what is the square root of the first? For x, what is the square root of the last? Three. So what is 4x times 3? 12x, and if we double that, does that give us this? Yes, so what are my dimensions? 4x minus 3 squared. Hands if you got that. Okay? So those are the dimensions of the cloth. What does that mean? That if they were to spread out the cloth, this would be 4x minus 3, 4x minus 3. Do you guys see that? Alright, but they want us to find, pay attention please, they want us to find the perimeter of the cloth when x is 11. So the perimeter is the measurement of all the sides, isn't it? Alright, so therefore, when x is 11, so instead of writing x, what do we write here? 4 times what? 11, 4 times 11. So 44 minus 3 is what? 41. And how many sides do we have? 4, so that's 41 times 4. And what does that give us? That's 4 times 1 is 4. 164 inches. And that's the perimeter.
But you have to put both answers.
What both answers?
You have to box both answers or just the same?
No, they're just asking for the, first the dimensions. We wrote the dimensions here, and then here's the perimeter. Okay?
So for non-word problems, do we have to simplify it all the way, like past 4x minus 3 squared?
Just as long as you leave it here.
Wait,
as long as you leave it as a factor, like this.
Oh, okay.
Alright, so now, that was one type of problem. The next one, hold on, copy this term down. The next term that I want us to cover was difference of squares. Difference of squares. This is the next type of problem, or next type of polynomial. Here we go. Difference of squares. So therefore, the definition is within the term. What does the word difference imply? What operation?
Oh, division.
Negative minus
Subtraction. Difference is subtraction. So what does difference of square mean? That it's two squares that are doing what? Subtracting. So let's draw that so you guys can see it. Here's one square. Here's another square. And they are subtracting. That's why it's called a difference of squares. Are we there? So let me give you first an example of a perfect square. We already know that 12 times 12. So what is a perfect square? 100. Oh, my bad. Yeah, I was testing you guys to see if you were paying attention. So, who can give me a perfect square number here? 5 times 5 is 25. So, let's see how this looks like. Pay attention, please. Let's see how this looks like just without the actual square. Here it goes. 144 minus 25. So, watch. Look up, please. These are the two things we need to do in order to find out if this is a perfect, a difference of squares. Watch. First of all, the word difference means that they're subtracting. Are they subtracting?
Yes.
Yes. The second thing, are they two terms?
Yes.
Yes. So this is how we check to see if they are perfect squares. Square root of the first, 12. Square root of the last, 5. And if it is a difference, therefore my factors are 12 minus 5 times 12 plus 5.
Wait,
Copy that. Let me show you another difference of squares. Here he goes. 100 minus 9. This 25, I just made it up. 5 times 5.
Oh.
Yeah, I'm making up these numbers. So 100, I got it from 10 times 10. 9, I got it from what? 3 times 3. So let's see. First of all, is it a difference? Yes. Is it two terms?
Yes.
Yes. So let's see if we didn't know if it was perfect square, what would we do? Square root of the first? 10. Square root of the last? 3. So if it has a minus here, then therefore our factors are 10 minus 3 times 10 plus 3. That's it. That's what we call difference of squares. So now that we did it with numbers, guess what?
Oh, we're doing it with
Let's do it with algebra. Here it goes. Yeah. Oh, that's the pattern. Alright, here we go. So, copy this one, please. You don't. Example 4a, just copy x squared minus 4. X squared minus 4. Here he goes. So, let's find out if this is a difference of square. Is it subtracting?
Yes.
Is it two terms? So far so good. Square root of the first. X. Square root of the last. 2. If it did, then therefore my factors are x minus 2, x plus 2. And how can we check? I already showed you how to check, didn't I? How can we check if that's the correct answer? What do we use? Area model. Let's see. X minus 2, x plus 2. Let's see. What is x times x? X squared. X times 2, 2x. Negative 2 times x, negative 2x. Negative 2 times 2, that's negative 4. So let's see. X squared is right here. What is 2x minus 2x? Cancel. And what is the last term? Negative 4. So we end up with x squared minus 4. Is that what we started with? Yes.
Let's just use, give me like 5.
Let's do another one. Copy this one.
Straight out of the oven. How, right in the system.
There it is. Copy this one, please. Example 4B.
40,
3p squared minus 9q to the fourth.
3p squared minus 9q to the fourth.
Let's see. Is it a difference? Yes. Is it a binomial?
Yes.
Let's see. Can we find the square root of the first?
No.
No, so this is not a difference of squares.
Not as good.
Mr. Q, I think we should just cut it there and let this all just think in our head.
Yeah, let's do another one. Copy this one, please.
Wait, what did we write down? Not a...
Difference of squares. Here we go. X to the fourth minus 25y to the sixth. Let's see. First of all, is it a difference?
Yes.
Is it a difference? Yes, because it's a subtraction. Is it a binomial?
Yes.
Yes, so let's see. Square root of the first. X to the second. Square root of the last.
5 to the third.
5y to the third. And if it's a subtraction, my factors are x squared minus 5y to the third times x squared plus 5y to the third. And those are my factors. Home plate for tonight is found on page 554, 555. Have a good one, guys. Enjoy your home plate. See you guys tomorrow.